Section 2.5 continued. We're going to be looking at even and odd functions. A definition of a function that is even is that f of x is equivalent to f of negative x. So when you look at these graphs, they are symmetric with respect to the y-axis. That is, if you choose a point on the right, say x comma y, then the point directly across from that would be negative x comma y. Notice that the y values are the same. Whereas for a function that is odd, f of negative x is going to be equal to negative f of x. Odd functions are symmetric with respect to the origin. Notice if we choose the point x comma y in the first quadrant, the point directly across from it will be negative x comma negative y. All right, so let's take a look at an example so you can see what I'm talking about. So for example, let's say we want to determine whether the function is even, odd, or neither. So it could be neither. Let's first look at, say, f of x is equal to x squared plus x. We want to determine whether this function is even, odd, or neither. First thing we do is try to determine whether it's even. To do that, everywhere we see x in this function, we're going to replace the x with negative x. So we'll have negative x squared plus negative x. Of course, we want to simplify that, and we see that f of negative x is equal to x squared minus x. Well, we look at this function, and according to definition, we said f of x has to be equal to f of negative x for it to be even. But because these two are not equal, that is here and here, they're not the same, we say that this is not an even function. Okay, so now we want to determine whether the function is odd. To determine whether the function is odd, we start with where we left off. We start with f of negative x. From this function, we factor out a negative. If when we factor out the negative, we're left with f of x inside of the parentheses, then this function will be odd. So let's take a look at it. From x squared minus x, I'm going to factor out a negative. So when we factor out a negative, signs change, so I'll have negative x squared plus x. The question is the part inside of the parentheses f of x? The answer is no. This is not f of x inside of the parentheses. So therefore, this function is not odd either. So our answer for this problem is neither. Okay, let's try another problem. Okay, this time let's say we do f of x is equal to x to the fourth minus 4x squared. All right, first step is to determine whether the function is even. So we replace x with negative x. Everywhere we see x, we're going to put negative x. All right, so when we simplify this, we have f of negative x is equal to x to the fourth minus 4x squared. Now, when we look at this, we see that f of negative x is the same as f of x. So that means this function is even. And we can stop right there. And this is, again, even because f of negative x is equal to f of x. So that's why this function is even. All right, one more.